Hey guys, let's do the palindrome linked list today. And that sounds like a very interesting problem. Given a singly linked list, determine if it is palindrome. So, what's a palindrome, by the way? Palindrome is something that reads the same whether you start from the front or you start from the back. So that is why the example 1 is false, because 1 2 is not the same as 2 1. Now let's take example 2, which is 1 2 2 1. Now this is same whether you read front or from back. So 1 2 2 1 is the same as 1 2 2 1 either way. So that is cool. So you say output is true. So that's what we need to figure out if it is palindrome. How do we do that? What should be our approach? And Let's try to do it this time in C++, or I mean I could have used Python, but you know what, it might be a good idea to do this in C++ because we get C kind of syntax, and at the same time we may be able to leverage some of the data structures from C++ STL. So one thing you find is that one approach that can be taken is that let's take the case where he gave us input of 1, 2, 2 and 1. If we have to find that this is basically a palindrome or not, intuitively you would think that hey, let's start walking from the front and let's start walking from the back and then keep comparing them. As long as the comparisons turn out to be alright, it is a palindrome. So now how do you start walking from the back? Because first that means you have to go walk once to the end of the list. And first of all, you cannot walk back because it's a singly linked list. There's no way to go to the previous. You can do next pointer, there's a next here, but there's no previous. So you cannot walk it back. So then what other approach can we take? Other approaches that we think we should be able to take is that how about a neat data structure known as stack? I'm sure we have all heard of that. And the stack's property is, if you think about it, what is the property of a stacks? Which is that last in, first out. If that is the property, then when we push this on the stack, what would the stack look like? Remember, the first thing we would do is let's try to do it in the way the stack actually is. They say the stack grows downward. So we push 1, then we push 2, then we push 2 again, then we push 1. Now when you try to pop it, you will be popping from the last one pushed. So now imagine we have pushed all of these elements on a stack and we start walking the list again, and then as we iterate through each element, we pop one element from the stack, compare them, and if they are equal, that means we are okay, but if they are false, it is not a palindrome. So in this case we would be at 1, we would be 1, everything is good, then 2 and 2, so this would actually turn out to be true. So that's the approach let's take. So whereas in the case which is 1 2, imagine we push the 1 and 2 in the stack, so the stack would look like this up to this point here, and now you start walking from here and compare, and then you will see 1 is not equal to 2, so that will be false. So let's just start by having a temporary pointer temp which is pointing to head and a stack of integers s. We say, so first let's build the stack. Let us add all the list elements to the stack s. So how do we do that? We say while, in this regard C++ being a close sister of C, we find that it's quite easy. So while temp, we just say that um, dot push temp val, sorry, and then we say s equal to s next, sorry, temp equal to temp next. So we have built the stack. Now what we're going to do is we have to walk the list again. So let's reinitialize temp to head. Again the same thing, while temp, and then we will say if s is pushed out. So now start popping each element. So imagine we say something like int x equal to s dot top. So by the way, you have to do this in two steps. So first thing is get the top of the stack, which is basically the bottom of the stack, and then uh, after that compare. So basically we will say if temp, compare it with the list element where we are right now, is not equal to x, we have a problem, we need to return false right away. Else, okay, there's no else. What we would do is we will do that in outside the this while loop, outside these loops. So now let's go and iterate through the next element, temp equal to temp next. All right, so this is our while loop, second while loop, which ends here. And if we come here and we haven't returned false yet, then we know it is palindrome and we return true. So let's see if that does it. Wow, there you go. So you got it right. This absolutely worked fine. And let's try to submit it and see if that passes as well. And he's saying that's the wrong answer because you said if so. Why is the answer wrong? Because 101 output turned out to be false, but it should have been true. And why that is the case, let's take that. So imagine we would have built this stack. If you look at like 101 and we start walking, so 1 is equal to 1, and then we take 0 from there's a temp val which is 0 is not equal to x, and when we pop it we get 0, but temp val is already in this case false, so is not equal to x. Now why is that the case? Why is this creating a, why did we return false here? What is x here? Let's try to debug this. So we say let's try to a C++ style of saying what is x here. So if x is equal to, or we can simply do this. So let's see why it failed. What is the problem here? X equal to, I see. We actually have to do something like this. And then X and then this. So now let's see. Missing terminator. Oof. So this is, as you can see, that was fine, but now let's come to our test case and give it 101 and see why that was failing. So now let's run the code again. and is saying that for x equal to 1, okay, again we got x equal to 1. So temp val, if temp val not equal to x, and what is the value of temp val here, by the way? So if x is this, temp val is, so temp val, alright, so the problem is that we have, as you can see, it's very clear what is going on here. What's going on is that you have x coming out as 1 and temp val was 1, so everything was fine. Then x was coming out to be 1 again, which is surprising because you know what? Shouldn't the top of the stack be 0? That's surprising. That's very surprising. While temp s dot push temp val, do we have to make sure that temp val did it really push the? Why are we getting the x is 1 here? Shouldn't x be 0? And that sounds like very confusing. So let's see why we are. Oh, I see what's happening here. The bug is very clear, as you can all see, because we did not pop it here. Without popping, you'll continue to get whatever was in the top of the stack. So we have to say s dot pop. That luckily turned out to be an easy fix, and I think that should take care of it. There you go. So that basically takes care of it. We don't need to have this count cout anymore, and basically we can comment that out. We don't need to delete. So run code again, and there you have it basically. So yeah, so that was a good catch. That just not enough to do a take what is at the top of the stack. You need to pop that one out so that the next time around we are in good shape. So there you have it, your answer to the basically. Okay, so that passes as well. So this pretty much can be considered a very good solution to palindrome linked list. And I use C++ only because it gives us this neat data structure known as a stack, which has the property of last in first out. I would have loved to do that in C as well, but I guess in C it might be a little bit more involved because we have to go and implement the stack ourselves. The C library does not give us stacks, queues, or any of these fancy data structures. So there you have it, and hopefully next time we'll try to do this in C as well. We may have to implement a stack, but until then, I wish you all the very best for your coding success in life, and may God bless you. Take care. Bye bye.